everyone, I'm Chen Jing, a dermatologist of the first affiliated hospital of Chongqing Medical University in China. It's my pleasure to share my work to you about SFRP5 inhibits the melanin synthesis of melanocytes via Wind beta-catenin signaling pathway in vitiligo. Vitiligo is an acquired chronic depigmentation disorder characterized by the destruction of melanocytes in the epidermis. Due to its complex pathogenesis and limited treatment, it has been a hot and difficult point of dermatology research in recent years. Wind signaling pathway is known to play an important role in proliferation, migratory, and differentiation in vitiligo pigmentation systems. SFRP5 is a member of the SFRP family, which are a class of secreted proteins. SFRP5 could inhibit the activity of the Wind signaling pathway by competitively inhibiting the freeze receptor. In cardiovascular disease and the type 2 diabetes, SFRP5 is thought to inhibit the activity of the Wind signaling pathway. However, the role of the SFRP5 in vitiligo remains unclear. So there has some hypothesis. So we speculate that SFRP5 may inhibit the melanin synthesis of melanocytes by inhibiting the Wind signaling pathway, thereby leading to the development of vitiligo. We just guess the SFRP5 plays an important role in the occurrence and development of vitiligo, and also it may promote the progression of vitiligo by inhibiting the melanin synthesis of melanocytes, and also may inhibit the melanin synthesis of melanocytes by inhibiting the Wind beta-catenin signaling pathway. Choosing sample, cell experiments, examination, exploration, viral experiments. We got some information of SFRP5 in vitiligo. The endogenous SFRP5 expression was higher in vitiligo lesion compared with the peri-lesion normal skin and the normal health control, Fig 1a. The expression of SFRP5 at mRNA and protein level was significantly increased in PIG3V cells compared with the PIG1 cells, Fig 1b and c. To investigate the role of SFRP5 in the regulation of melanogenesis, the results shown that SFRP5 significantly decreases the level of tyrosine activity, Fig 2b left panel. Also, there was a significant decrease in the melanin contents, Fig 2b right panel. The level of alpha-MSH expression was obviously decreased, as shown in Fig 2d. In addition, the number of the dendrites was also detected by scanning electric microscopy, and the results indicated that overexpression SFRP5 remarkably decreased the number of dendrites. The number of melanocytes was also decreased, as was assumed by transmission electron microscopy, Fig 2e. Furthermore, the effect of the SFRP5 downregulation on melanogenesis was also examined. As we can see, SFRP5 knockdown significantly downregulated the tyrosine activity, left panel, and the melanin contents, right panel, of PIG3V cells, Fig FIG2C. Consistently, the expression of alpha MSH was remarkably raised. FIG2F. The numbers of dendrites and melanocytes were also increased by SFRP5 downregulation. FIG2G. Taken together, these results indicate that SFRP5 has an inhibitory effect on melanin synthesis. To investigate whether SFRP5 affects the expression of melanogenesis-related proteins, we further examined the mRNA and protein expression levels of melanogenesis-associated protein MITF, TYR, TRP1, and TRP2 in PIG1 cells after treated with SFRP5 RFP as control. And we found that the mRNA and protein levels of them was significantly decreased in the presence of SFRP5 overexpression compared with control, FIG3A and B. As the high expression of SFRP5 in PIG3V, the effect of the SFRP5 downregulation in PIG3V was examined. As shown in FIG3C and 3D, the silencing SFRP5 significantly improves the mRNA and protein levels of the melanogenesis-associated proteins. SFRP5 is known as an antagonist of Wnt signaling pathway. It's unclear whether the effect of SFRP5 on inhibiting melanogenesis can also be mediated through that pathway. Hence, we examined the effect of SFRP5 in the beta-catenin signaling pathway in melanocytes. SFRP5 downregulation was associated with decreased level of the GSK3 beta, resulting in the decrease in the beta-catenin at SFRP5 residue phosphorylation and the total beta-catenin level. FIG4A. Consistently, SFRP5 knockdown significantly increased the phosphorylation of GSK3 beta and beta-catenin. FIG4B. We also performed an TCF LEF luciferase reporter analysis to investigate whether SFRP5 inactivates beta-catenin signaling. Treatment of SFRP5 inhibits the luciferase activity and green fluorescence protein expression in PIG1 cells, while the PIG1 cells treated with SI-SFRP5 shows a higher luciferase activity compared with GFP. Finally, and this is FIG4C. Finally, to further confirm the effect of beta-catenin signaling on melanogenesis, double immunocytochemical staining was performed. A confocal microscopic examination showed a significantly reduced proportion of nuclear beta-catenin in PIG1 cells that overexpression SFRP5, FIG4D, coincide with which there is an obviously increased proportion of nuclear beta-catenin in melanocytes in the presence of SFRP5 downregulation. FIG4E. To further confirm the role of the Wnt beta-catenin signaling pathway in the function of SFRP5 on melanogenesis in PIG1 cells, SKL2001 was used to activate Wind beta-catenin signaling pathway. As shown in Fig 5b, after treated with SKL2001 independently, the expression level of melanogenesis-associated protein MITF, TYR, TRP1, TRP2 were significantly increased. In addition, beta-catenin activation abrogated the downregulation of levels of melanogenesis-associated proteins. Compared with the SFRP5 control group, Fig 5b, consistently, the level of tyrosinase activity was also reversed after the treatment with SKL2001, Fig 5c. Furthermore, we use B16 cells to establish an external graft model in nude mouse. The results showed that the skin was slightly lighter in the SRP5 group compared with that in the control group. Similar, the skin in SRP5 group showed a hyperpigmentation compared with the control, Fig 6a. Subsequently, ex-survivor mouse skin were used with IHC, and the results showed that the expression of alpha MSH was decreased in the SRP5 group. Consistently, the SRP5 group showed higher alpha MSH expression, Fig 6b. So, as it is shown in the figure, in normal melanocytes, overexpression of SRP5 inhibits the Wind and then reduces the accumulation of beta-catenin in the cytoplasm. Subsequently, reduced beta-catenin entering the nucleus. We use SKL2001 to activate beta-catenin, increase its entry into the nucleus, and then proceed nuclear translocation to start the transcription and translation of downstream target genes. In vitiligo melanocytes, we knock down the SRP5, then the Wind signaling pathway is activated. Beta-catenin accumulation in the cytoplasm subsequently enters the nucleus. Nucleus translocation occurs and transcription and the translation of downstream target genes are initiated. So in this study, we first explored the effect of SRP5 on the biological function of melanocytes in vitiligo from the cellular and animal levels. It was found that SRP5 could inhibit the melanin synthesis of melanocytes by inhibiting the Wind beta-catenin signaling pathway, which could be a promising therapy approach for treating vitiligo. But also, our work is not enough. We should do more in the future. Thank you for listening.